Hello everyone, welcome to today's webinar. Today we will go over Unit 4, Exponents and Rules. Today we're going to cover only the first section of the fourth unit under Algebra 1, and this section is only about exponents, which is powers. This is myself. My name is Miriam. I'm your math instructor here at Penn. I'm certified to teach high school math in the state of Pennsylvania and also have my master's degree in education. In this webinar, we're going to go over the most challenging type of questions that you may see in the first section of this unit. Also, there will be some self-check questions for you to try. Those questions are not graded. I don't base my assessment to you or the points you're going to receive in this course depending on those questions. Those questions are provided for you just to self-assess yourself and see if you need help in some of the topics or you're fine, and that may be a sign for you that you're ready for the exam. You can ask your questions. Please keep them relevant to what we discussed today during our webinars. The raise your hand feature does not work, so you want to type in your questions if you have any questions for me. All registrants for this webinar will have a recording. Either you attend or you're absent today, you will receive a follow-up email with the recording. Today in this webinar, we're going to go over how to evaluate exponential expressions. So exponential expressions are expressions with some variables that has exponents or powers. We're going to learn how to add, subtract, multiply, divide exponential terms. We're going to learn how to raise exponential terms to a grand or an outer power. And also we will learn how to write big, so large and so small numbers in scientific notations. Let's start with the basics of the rules of powers, the rules of exponents. Now, the basic operations are addition, subtraction, multiplication, and division. We need to be careful when we deal with exponents. It may seem that when we add terms that has powers that we may have to add the powers. That is incorrect. When we add exponential terms, so negative 16y squared is an exponential term. It has a variable raised to a power or to an exponent, and that's why we call it an exponential term. When we add multiple terms like these, we do not add the exponents. We actually make sure, one, that all of the variables are exactly the same, which is true in question 1. We have y squared, and y squared. From unit 1 in this course, if you remember, we called those separate terms monomials. And also we said if a monomial has the same exact variable part, we call them like monomials. And in that case, we just add the coefficients of those variables and keep the variable the same and keep the powers the same. So to add this expression, all we need to do is to add the coefficients. Coefficients are the numbers that appears before the variable. So we are going to add negative 16 and 5 and negative 2. Add that together and that will give you the coefficient of the answer, the coefficient of the exponential term and your answer. So it's going to be negative 13, and then keep the variable the same with the same power. Do not add the powers. So that is the common mistake that I see in exams, that when students are seeing a question that says add and they see exponents, they add the exponents, which is not correct. Question number 2, the same thing here. T cubed minus 2t cubed plus 10t cubed plus 3t cubed. I'm going to look at the variable parts. All of them are t's. All of them has the same power. So I'm going to go ahead and add the coefficients only and keep the variable with the same power the same. So if you remember from the very beginning of that course, we said that 1 in algebra, we don't write that. So that is 1t. So we're adding 1, negative 2, 10, and 3. Add that together and that will give you 12. And then keep the variable part the same with the same power. This is how we add exponential expressions. The last question on the screen, 6x plus 6x x squared minus 7x minus 10x cubed plus x squared. Looking at these expressions, we realize that all of them are x's, but not all of them has the same power. So that makes us not to add all of the coefficients together. We need only to add the coefficients of the same exact variable with the same exact power. So the like terms, the like monomials in this question are 6x and also negative 7x. These can be added together. The coefficients can be added together. 6 minus 7 is negative 1. So it's going to be negative 1x, which is negative x. I'm done with the two terms there. I also see two of the x squared. I have 6x squared, and also I have I have plus x squared. These have the same variables, the same power, then add the coefficients. 6 and 1 is 7. So it's going to be 7, and keep the variable with the same power. Now, negative 10x cubed doesn't have a like term, doesn't have a like exponential expression, so it will stay the same in our answer, negative 10x cubed, and that would be your final answer. Usually in algebra, we order the powers of variables from the biggest to the smallest. So this answer is a correct answer, but it's just a habit that we need to keep is that to write the greater powers first. So we're gonna rewrite that as negative 10x cubed and then plus 7x squared minus x. These two answers are the same, it's just the way we write it in algebra. Any questions? Anything that was not clear? Anything that was not the same as you've read in your study units or lessons? During the webinar, you're going to see that those brackets will have some notes for you to keep in your notebook if you keep a notebook for your lessons. So these will have like a shorthand of the rules that we use to add or subtract exponential expressions. Also, the rules that has those symbols will just summarize the rules in terms of algebra. So the rule that we have been following so far in this slide is that if I'm adding ax to the m power plus bx to the m power, here x to the m and x to the m, they are the same variable, the same powers, then the rule says add the coefficients a and b and keep the variable with the power. And that would just give you an idea of what is the rule is, and instead of just going back and forth to the lessons and try to find the rule. Any questions? For those who have just joined us now, if you have a question, you can type in your answers in the questions box. Now, after each discussion, we're going to have a self-check question. These are not graded. This is a question on what we've just went over, adding or subtracting exponential expressions. This is the question. These are the answer choices. Also, in about 30 seconds, I'm gonna switch my screen. I'll give you the same exact question, the same exact answer choices, but that time when I change my screen, you'll have an option actually, and you're gonna have the ability to select your answers, and I'll be able to see the stats of your answers. Who got the not who, but how many percent of you got the correct answers and how many percent of you did not get the correct answer. And really, it does not mean anything as far as your grade in this course. It's just an assessment method that we are using here in this webinar. So here's the question. We are going to simplify 35c squared minus 3c plus 3c squared plus 13c cubed minus c. What should I do? What should you do? Which rule? Which variables I should add the coefficients for? I'm going to change my screen to give you the same questions and the same answers. So please participate and just, to have the sense of the classroom. It's a virtual classroom, so it's good to interact and, participate in the discussion. So here's the question. Okay, for those questions, I'm going to share my final answer. If you have a question on how we got this final answer, you can type in your question and I'll try to go quickly over the question. Also, another way to get a benefit from those questions is that when you get the recording and you get one of these questions, you want to pause the video, copy down the question, work at your pace on the question, and compare the answer that you get and the answer that we're going to share right now. The answer for that is B. B is the answer. Now, A is not the answer because if you look at the question, you are adding negative 3C and negative 1. Negative 3 minus 1 is not negative 1. It is negative 4. So anything that has anything else other than negative 4C, that would be an incorrect answer. So that would be negative C here. This one is not correct. This one does not have a C at all, so that's not correct. And this one is not correct. Our answer has to have a negative 4C. This is a way that shows you how to eliminate answers in multiple choice exams, or if you're doing the SAT or ACT, you don't have to exactly work on the question till the end. You can just have some clues from maybe the first part of your answer. And depending on that, you can eliminate questions. And we're so lucky that we were able to eliminate 3 out of 4. So of course the answer is B. If you go ahead and finish off the answer, it should be exactly the same as this answer B. Next, let's look at multiplying exponential expressions. What are the rules? What should we do? If you have questions, I see some of you have the raise your hand button there. If you have questions, you can type in your questions in the questions box. So how can we multiply the exponential expressions? Multiplication is, again, has a different rule that we may have in mind. When we multiply exponential expressions, we are going to add the exponents. The exponential expressions does not have to have the same exact variables. We can just multiply them. The only difference is when we have the same exact variables with different powers, we are able to add the powers. If we have different variables with or without the same powers, it's not going to matter as long as the variables are different. We can just combine them in the answer, but we were not able to add those powers. With those questions, I'm going to explain more what do I mean. So for question 1, 2y cubed times 7y to the fifth. In this case, we have the same variable, y and different powers. With multiplication, it's not a big deal. It's not it's not something that you have to have the same powers. You may have the same variables, different powers. You may have different variables with the same powers. You may have different variables with different powers. We can work with all of these. With addition, we only limited to adding only the exact variable with the exact powers. In here, what we're going to do is multiply the coefficients. 2 times 7 is 14. And then multiply the variable parts by keeping the variable y and then add the powers. 3 and 5, 3 plus 5 is 8. And that's your answer. So even though we are saying multiply this question, we are actually adding the powers. I'm just going to check on the questions. Okay, Tiffany had a question on the previous self-check. I'll go back to that and I'll show you how did I come up with a negative 4c, not a negative 1c. Thank you, Tiffany, for your question. I will go back to that. Okay, question 2, multiply negative 5p to the 6th powers times 10p to the 5th power times 6t to the 10 power. Now I have two different variables in my question. I have p's and I have a t. What should I do? Well, the rule says if you have the same variable, add the power. If you have different variables, you're just going to keep the same thing, just combine them in your answer. I'm going to show you how. So since we have p to the 6th and p to the 5th, we are able to keep the p and add the powers. 6 and 5, 6 plus 5 is 11. And don't forget to multiply the coefficients. Negative 5 times 10, negative times a positive will give you a negative answer. 5 times 10 is 50. And still I have to multiply that times 6t to the 10. Well, I have a p and a t. I cannot add the powers in this case. I don't have the same variable. What I can do though is just go ahead and multiply the coefficients. Negative 50 times 6 will give you negative 300. And then combine the variable just by writing them beside each others without the multiplication sign. P to the 11th power, T to the 10th power. That would be your answer. We were not able to add the powers in this case. Last question in that screen, 9x to the 8th power times 5x to the 2nd times negative 3r times 4w to the 2nd power. Now I have two terms with x's there, different powers, but it's not a problem because we're multiplying. In this case, we are able to add the powers. So 9 times 5 will give you 45. And then multiply x to the 8th times x to the 2nd. So in this case, you will be adding the powers. So it will give you x, and then 8 plus 2 will give you 10. I'm not done yet. I still have to multiply times negative 3r and times 4w2. W to the 2nd, I'm sorry. Now, r and w are different than x. Nothing I can add the powers for. So I'm going to go ahead and just multiply the coefficients. 45 times negative 3 times 4, it should give you negative 540. And then combine the variables and just taking out the multiplication sign. That's it. That would be your final answer. Any questions so far? Any questions so far? Before I go to the self-check for this, for these questions, I'm going to go back for Tiffany for the question that she had on the self-check. Now, how did we come up with negative 4c? Okay, well, negative 3, now we're adding. Now we're adding exponential expressions. That means we do not add powers. Okay, so we have negative 3c, Tiffany, and we have negative c. Well, negative c is actually negative 1c. When I do the addition or subtraction, I'm actually doing negative 3 minus 1. So when you're adding the two numbers with the same sign, we actually add the values. 3 and 1 is 4, but the answer should have the sign of the numbers. So the sign for the 3 is negative, the sign for the 1 is negative, then your answer should be negative as well. So when you're adding or subtracting the coefficients of the c, it turned out to be a negative 4, and then you have to write the c, the variable, multiplied to that. And that's why we said any answer that does not have a negative 4c would be an incorrect answer. Did I answer your question, Tiffany? Okay, let's move on to the self-check for multiplying the terms. Multiplying terms meaning adding powers for the same variables. We need to remember those rules. Okay, simplify negative 8q times 5t squared times 6q to the third power times t to the fourth power. We're going to look at the question. I know the first thing you're going to do is to pick out the variables that is the same variable, q and q. And then you add the powers and don't forget to multiply the coefficients. I'm going to have just that screen stays for about 30 seconds. You can work on the problem and then I'm going to switch my screen to give you a chance to share your answers. Okay, I'm going to change my screen now to give you the same question with the choice of sharing your answer. Okay, I'm gonna do that question with you quickly because it's a short answer here. I mean, short question. So what I'm gonna do is look at the q and look at the q, the same variable. We're multiplying and then add the powers. So it should be q to the fourth, and then multiply the coefficients. Negative 8 times 6 will give you negative 48. I'm not gonna go and see about the coefficients now. What I'm gonna see to eliminate my answers, anything that does not have a q to the fourth is an incorrect answer. So this one has a q to the fourth. I'm gonna keep that. This one does not. That's wrong. That is wrong. And this one, it has a fourth, although the answer looks like that we have to add, which is incorrect. We're multiplying. So the only answer is D. D is the only correct answer. If you go ahead and multiply all of the other coefficients and simplify the t's, you will end up with this answer. Negative 240 q to the fourth t to the sixth. That would be your answer. Any question here? Anything that is not clear? Okay, should I go ahead and do the question? I'm going to do it for you. So far we multiplied negative 8q and 6q to the third. And then we still have to multiply times 5t squared times t to the fourth. So I need to multiply the coefficients. Negative 48 times 5 will give you negative 240. Now we have q to the fourth, but we have t and t. We're multiplying, then add the powers t to the 6. 4 plus 2 is 6. Some students would do 4 times 2 is 8, which is incorrect. It's 6. We're adding. So negative 240 q to the fourth t to the 6. That's the correct answer. Okay, let's look at division. How can we divide exponential expressions? So dividing would look like a fraction because fractions is actually dividing. So you're dividing r to the fifth over r to the second. What are the rules? The rule says when you divide two variables which are the same, but they may have different powers, no problem. You're going to subtract the powers. You're going to subtract the powers. So following that rule, r to the fifth divided by r to the second is actually r to the third, because 5 minus 2 is 3. So that would be your answer. Number 2, the same rule. I'm dividing same variable y and y. I have different powers. It's okay. So my answer will have a y, and then subtract the top power minus the bottom power. Although 6 is less than 10, but we still have to follow the rule. 6 minus 10 will give you a negative exponent, y to the negative 4 power. Now, any variable raised to a negative power, that answer is not in simplest form. We need to switch it to the simplest form. How can I rewrite this answer in simplest form? Well, I need to follow another rule. This rule says if you have a variable here raised to a negative power, actually you can write it as is 1 over the variable with the exponent, but since we have the variable with the exponent in the denominator, we're just going to cancel the negative sign. So y to the negative 4 power, y to the negative 4 power equals to 1 over y to the 4th power. That negative sign tells you to put the variable in the denominator, or flip it. If it's in the denominator with a negative power, put it on the numerator. So that would translate to switching the variable. Flip it over. Okay, let's do a more complicated one. X to the 3rd power y squared z to the 7th power over x y to the 5th and z equals to. I'm going to follow the same rules. Although the question may look scary, overwhelming, I'm just going to focus on my rule. What the rule says. Subtract the powers of the same variables. So I have x to the 3rd, so 3 minus 1. 3 minus 1 is 2, so x to the 2nd. And then y to the 2nd and y to the 5th, top minus bottom. 2 minus 5 is negative 3. And then 7 minus 1 will give you 6. Now I see a variable with a negative exponent that is not in simplest form. What I can do is rewrite it as x squared z to the 6th over y to the 3rd power. And that would be your answer, your final answer, your simplest form of the answer. Any question? Anything that's not clear? Let's go to more complicated questions in dividing exponential expressions. Okay, now I see x cubed h to the 6th power y cubed over y to the 6th power h x to the 7th. Now, these are not in order, meaning that the x does not align with the x here. That may cause confusion. What I'd like to do is to reorder my variables. I mean, since the top variables are multiplied, the bottoms are multiplied, the order will not matter. So what I'm going to do is I'm going to just rewrite my questions for my convenience. So x to the 3rd, h to the 6th, and y to the 3rd. That top part will be the same. Now reorder the bottom part. So the x is under the x. So x to the 7th, I'm going to bring it to the front. And then next I have the h. So it has an h here, and then y to the 6th. Now I can, by looking at the variables, I can just match them and do the subtraction of the powers easily. Okay, let's do that together. So 3 minus 7 is a negative power. So you know what? Let me do that before I do the division. I'm going to write the negative powers and then flip them. So it's clear why did we flip the answer. So again, x 3 minus 7 is 4. So it's x to the negative 4. Negative 4. And then we have 6 minus 1. That is I'm sorry, 6 minus 1, and that's for the h, so h to the fifth. And then 3 minus 6, that would give you a negative power, y to the negative 3 power. Okay, that's not in simplest form. Flip the x and flip the y. So h to the fifth will stay on the top, x to the fourth, and y to the third power will go in the denominator. Any question? Okay, let's do a more longer question here. 66 p to the fourth q to the third s squared t over 11s squared t to the seventh q to the sixth times p. When I'm reading the question, I know that you can see my screen. I know that you can read it yourself. I just developed the habit of reading the question to myself. And since I'm talking to you, I'm reading it loud. So it is a good habit with math to read the question to yourself, to read every single number that appears in your question, to know what you are going to be doing. When you're reading a question, you're actually thinking of the question as you read. So you are warming up yourself for the upcoming process that you're going to do to get the final answer or to solve the equation or whatever you're doing. Okay, so I see that the variables are out of order. I'm gonna rearrange them. So I'm gonna keep the top the same. The bottom, I'm gonna rearrange. I have the 11 and then I have a P. The P here under there is a P, just P with the first power. Q is next. Q is to the sixth power. I have next the S, so the S to the second, and then finally I have a T. T is to the seventh power on the bottom here. Now it's easy for me again to look at the variables and subtract the power. Okay, now I have numbers in that question. I have to divide the numbers. 66 over 11 is what? 6. 66 over 11 is 6. Okay, next, p to the fourth and p. So that's 4 minus 1. So that will give me p to the third. Okay, I have 3 minus 6. 3 minus 6 is negative 3, so q to the negative 3. Okay, and then I have 2 and 2. 2 minus 2 is a 0, so I have s to the 0. And then 1 minus 7 will give me t to the negative 6. Okay, I see some negative exponents. I need to rewrite that in simplest form. So 6 and p to the third, that will stay on the top. On the bottom, I'm going to have q to the third and t to the sixth. What about the s? S to the 0. The rule says any number raised to the power 0 is 1. So it just cancels out. That's a 1. Anything times 1 is itself. So that's why we're not going to write anything for the s. S is just canceled out. So that would be your final answer. Any question? Okay, let's look at an example. It looks scary. It looks so overwhelming with big powers and numbers and too many variables. We do not care about how the problem looks. We are confident that we know the rule, we practiced, and we know how to apply the rule. So we'll take it one by one and do the problem. So I'm going to leave you look at the problem. The screen is switched. The problem itself is so weird the way it's written. So I'm going to keep that screen for a while to copy it down, work on it, and then I'll switch my screen to give you the chance to share your answers. I'm still here. I'm just waiting for you to think about the problem. It is important to do the problems yourself. Okay, I'm going to switch my screen and hopefully you had a chance to write the question down and begin working on it. So here's the question again. Okay, let me share my final answer on that question. The answer is D. D is the final answer. So that big thing here just ended up being v to the fifth over 5t to the third and w to the fourth. Anyone wants me to go over this question? Okay, let's move on to. Okay, I'll do that. I'll do that for Mendy and everyone else who wants to see that problem. The same thing, the same process that we have been following for dividing exponential expressions. So I'm going to rearrange my question. I just realized that they are not in order. So I'm going to keep the 7t to the 12th power, u to the fifth, v to the sixth, and w to the third the same, and then rearrange the bottom. I have the u appears first, so u to the fifth. I have v, so v here is just a v to the first. I'm sorry, I did a mistake here. It's t, that the one that appears first. So t is the one that appears first. So t to the 15th, and then u to the fifth. I have v to the first and w to the seventh. Okay, now it's easier for me. 7 over 35. 7 over 35 does not equal to 5. 7 over 35 equals to 1 over 5. To 1 over 5. So in my answer, I'm going to have a division sign. 1 is there. I'm not going to write that. It's algebra. I'm just going to just skip the 1 and write the 5 on the bottom. Now the variables. I have t and t. 12 minus 15 is 3. But it is 12 minus 15, so it's a negative 3. So I'm going to have a t to the negative 3 here. U and u, fifth to the fifth, so that will cancel out because eventually I'm going to have u to the 0, which is 1. And then 6 minus 1 is 5, so v to the fifth. And then w to the third, and w to the seventh. 3 minus 7 is negative 4, so w to the negative 4. Well, I have negative exponents. This is not the final answer, so I should rewrite it as v to the fifth over 5, t to the third, w to the fourth. That is the final answer. Okay, let's look at another operation that we may see in our exam or we will see in our practice question Discover More's and our lessons. What if we have an exponential expression like x to the seventh, and then we decided we want to raise that one expression to another outer power or a grand power? What's the rule on that? The rule says multiply the powers. Distribute the power, the outer power, over each term inside the parentheses that you're trying to raise the power, the grand power to. So since I have a one exponential expression in my first question, what I'm going to do is multiply 6 times 7 will give you 42. Then your answer is x to the 42nd power. That's it. Okay, let's look at a more complicated example. R to the fourth times p to the second, everything is raised to a negative power, negative 2. The rule is the same. Distribute the power, multiply this power times each one inside the parentheses. So I'm going to do R. 4 times negative 2 is negative 8. 2 times negative 2 is p to the negative 4. Now, these are not in simplest form. 1 over r to the 8th, p to the 4th is the final answer. Let's look at a more complicated question. We have now numbers. We have variables with powers raised to a grand or an outer power. The same thing, distribute the power. Now, the common mistake that I see students do is they distribute the power over all of the other powers and forget to raise the -5 to the third power. We have to raise everything inside that parentheses to the third power. So, -5 to the third, and then I'm going to raise everything else, z to the ninth, y to the -2, everything else is raised also to the third power. Now, -5 to the third power is not -5 times 3. It's -5 times -5 times -5, and that will give you a negative answer, -125. That's the value of raising the -5 to the third power. And then I'll do as usual, I'm going to distribute the 3 to each power here and multiply. So I'm going to have 3 times 3 is 9. So y to the 9th. 3 times 9 is 27, z to the 27th. And then 3 times -2 is w to the -6. Put it in simplest form. So I'm going to keep the the variables with positive powers up. -125, y to the 9, z to the 27th, and then w to the 6 would be in the denominator. That would be your final answer. Now, I have a rule they want to share with you, and these two things are the cause of confusion when we are raising an exponential expression to another power. I'm going to change the color to make it stand out in my slide. Two things that we need to keep in mind. We need to differentiate between 2 to the -3 power, for example, and -2 to the third power. These are so different. 2 to the -3 power does not equal to -8. That's not correct. It actually 2 to the -3 power equals to 1 over 8, because 2 to the third power is 8, and we have a negative exponent, so put it in the denominator. Now, what about this one? We are raising the number -2 to the third power. So you are multiplying -2 times itself 3 times. So -2 times -2 is 4, positive 4. And then 4 times -2 will give you -8. And this is where the confusion comes from. So you need to really make sure what you are evaluating there. Any question about this rule? Any question about why, or if you want another example? Another rule I want to share with you to keep in mind is that when we are raising a negative number to an odd power, so -2 to an odd power like 3, like 7, like 5, like 9. So that will result in a negative answer, -8. What about if I raise a negative number, like -2, to an even power, like 4? The answer will be a positive answer, So in that case, you're going to multiply 2 times 2 times 2 times 2 equals to 16, which is the same thing as multiplying -2 times -2 times -2 times -2. It will give you a positive answer, 16. So just to write a summary for that rule, and I hope that you write this somewhere on your notes. If you have a negative number raised to an odd power, that should give you a negative answer. If you have a negative number raised to an even power, that should give you a positive answer. So these two things here you need to be careful with when you're working with exponents. Okay, let's go on to more complicated questions here. What if I want to raise a fraction that has some exponential expressions on them to an outer power? What should I do? What should I do? It's a similar rule. Distribute the outer power over each of the terms on the top and the bottom. That's it. Now, the only tweak in that is, since I have a fraction, it is better to simplify the fraction before I raise the whole thing to the sixth power. So I'm going to do that. I'm going to do this. I'm going to keep the sixth power out. What I'm going to do is simplify my fraction. So I'm going to make my next step easier on me. So x to the second and x2 minus 1 is 1. So I have an x here. And then I have y to the fifth. So y to the fifth. And then I have z to the second on the bottom, no matching, so it's going to stay the same. Now I can raise the whole thing to the sixth power. So I'm going to distribute. So that would be x to the sixth, y to the 6 times 5 is 30, and then 6 times 2 is 12. And that's your final answer. That's your final answer. Okay, let's do 5. We have negative numbers, we have powers outside and inside. What should we do? First, I'm going to simplify my fraction. Keep the third power outside. I'm going to simplify negative 3 over negative 9. It's not 3. It's going to be 1 over 3, and it's going to be a positive third. So 1 over 3. Okay, and I can rearrange everything too to make it easier if you want to add that as a step. So I have t to the second so far, s to the third, rearrange t, and then I have s to the seventh. So that way it is more easier than this setting. So I'm going to keep the third power. I did not distribute the power yet. So I need to simplify. I have the 3. I have to the second, to the first. 2 minus 1 is a 1, so t on the top. I have s to the third and s to the seventh. 3 minus 7 is negative 4. Negative 4. So I'm going to right away write it as s to the fourth in the denominator. Now I distribute the power over the t, the 3, and the s to the fourth. So t to the third, because 3 times 1 is 3. And then I have the 3 on the bottom here. So I need to cube the 3. And then 3 times 4 is 12. Simplify. So I have t to the third over 3 to the third power. 3 times 3 is 9. 9 times 3 is 27 on the bottom here. And then s to the 12th power. And that is your final answer. So one thing I need to mention, because powers are difficult concept to grasp, and also roots, when we go over the second section of the unit, we need to maybe at the beginning write each step down on our paper. We need to practice a lot before we skip some steps. So that problem may look easy, but I just had to write down 4 steps for me to be able to ensure that I'm following the rules, I'm not mixing up powers, I'm not doing anything I'm not supposed to do. So it may be boring at the beginning, but as you practice, you will just skip some steps along the way. Okay, let's go back to the questions. So this time I have a fraction with some numbers and variables, powers, and an outer power that's a negative power. What should we do? Same rules. Ariana is asking, is it okay to change the order of the bases? Yes, it is okay as long as the top here, here, the top here, the numerator, all the terms are multiplied. So if I want to write this as -3 s to the third t to the second, for example, it's the same as here, as long as all terms are multiplied. So in that case, yes, you are okay to change the order of the variables. Number 6, we have 15a cubed b to the fifth c to the sixth over 5b squared c to the sixth and a to the fourth, everything raised to the -2 power. I'm not going to care about the power now. I'm going to simplify my fraction to make it easier for me. So 15 over 5 is 3. So it's not going to be a third. 15 over 5, 15 is greater than 5, so our answer has to be a whole number, not a fraction. So 3 is going to be on the top. Now rearrange the variables because I need my variables to look good for me to work with. I have to keep the power outside. I did not touch it yet. So I have a to the third, b to the fifth, and c to the sixth. Rearrange the bottom. So I have the a first, which is going to be here a to the fourth. I have b to the fifth, so it's going to be matching with b to the second. And then I have c to the sixth power. Now simplify. Keep the power outside. I did not do anything with it yet. I have to remind myself and remind you that we do not mix up steps. 3, and then 3 minus 4 is -1. So -1, I know I can skip that step now. -1 should make my a appear in the denominator. It's a negative power. Okay, b to the fifth and b to the second. 5 minus 2 is 3, positive 3, so b to the third. C to the sixth, that would be canceled out. So now I have only this tiny fraction to work with in terms of the outer power. Now distribute. I have to raise everything inside that fraction to the power of -2. So 3 to the -2 power. B, 3 times -2 is -6 over a to the -2 equals to, I have lots of work to make this in simplest form. Let's evaluate the 3 to the -2 first. Okay, well, 3 to the second power is 3 times 3 is 9, but we have a -2, so the 9 has to appear down in the denominator. B to the -6, it's a negative power in the numerator, then flip the b. So the b should appear now in the denominator with the 6th power. A to the -2 in the denominator, flip the a and keep the second power on the top. That would be your final answer. That would be your final answer. So always the negative sign of our power makes us flip the variable over. If it's on the top, it will become on the bottom. If it's in the bottom, it will become on the top. Any question? Okay, let's look at a self-check question. It's overwhelming, it's so scary, but remind yourself, you know the rules, you've practiced. We are so clear on what steps that we should do in order, so there's no need to panic. Just do what you need to do, rearrange, divide, subtract powers, apply the outer power, and that's it. I'll give you the chance to look at the question here because it's more neater in that slide, and I'll be quiet for about a 30 to 40 seconds to give you a chance to think about the problem. Okay, I hope that you copied down the question and you began the question. I'm gonna switch my screen. So if any of you is ready to share their answer, they can. Here you go. Okay, I'm going to share my answer. Let me know if you want me to go over this question. We are almost out of time. But I'll um, stay with you for a few extra minutes to make everything clear before we end our webinar here. So the answer for that question is C. C is the right answer. Anyone want to see that question, since it's a big question here with lots of high powers and an outer power? Or you're okay, whenever you receive the recording you can just work it on yourself and see if you had question later you can email me or text message. Okay, I'll move on then. Okay, another topic, which is the final topic in today's webinar, is scientific notation. Scientific notation is a way to abbreviate very large numbers and very small numbers. Like in the space, they use so extra large numbers. So instead of writing that huge numbers with that many zeros that's so confusing to even write and work with, they invented the scientific notations. Scientific notations, they use the base of 10 and give the 10 a power. That power will make the representation more abbreviated, and it's still have the same value of that huge number. So let's look how can we represent this decimal notation or this numerical notation to scientific notations. First, it's a whole number. We know that this huge number is a whole number. We know that the decimal point appears here. We do not write it because there is no need to, but we know theoretically that the decimal point would appear after the number. To represent that in scientific notations, I need to have only a whole number which has one digit, only one digit in the whole number place value, and then whatever decimals they need to appear in our number. So what I'm going to do is move the decimal point to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to stop at the 11th move because I need one whole number appearing in my scientific notation. So by moving this decimal point to the left 11 places, I'm going to have this 4.56. And then here's the new part, times 10. How many places did we move the decimal point to the left? 11, to the 11th power. That would be the scientific notation for this huge number. So I moved to the left, and I needed to write the power in positive number. So it's positive 11, not negative 11. Okay, what if I have an extra small number? I am going to do the same thing, but my directions will change. So the decimal point in this case is so obvious. It's a decimal number to begin with. So I'm going to move my decimal point to the right. So I have one whole number in my scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I need only the 6 to be there as a whole number part of my number. 6.58 times 10. And how many places did we say that we moved the decimal point to The right, it's 9. But since we moved the decimal point to the right, my exponent have to be negative 9. So it's 6.58 times 10 to the negative 9th power. This is the same as writing out this huge or this extra small number. This is the whole idea of scientific notations. Just moving the decimal point right or left and then giving the 10 either a positive or a negative exponent. Any question? Any question? Okay, let's look at more examples. More examples. Okay, represent the following numbers in scientific notations. It's a huge number, it's a whole number. I know that the decimal point appears here, and I need to move it as many places as I can, so I have only the 4 as a whole number part of my scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm gonna, before I forget, it's 10 places times 10 to the 10th power before I forget. And then from the look of here, I have 4.05. So that will give me the whole scientific notation of this big number. Number 2, an extremely small number. So I need to switch, I need to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8. Before I forget, it's 8 times 2 times 10 to the negative 8th power. And then I'm going to write it out as 1.022. So in all cases, I need to have one whole number, just one place in that. I cannot have a 14, a 23 there. I need to have only one place in the whole number part of this number. And that is how we're going to write the scientific notations of these two numbers. Okay, a self-check question, the same idea. You have an extremely small number. You're trying to represent that in scientific notations. I'm going to just put the other screen on because the question appears good in the other screen. So here you go. Which one is the correct scientific notation? Okay, I'm going to share my answer. And the answer is B. The answer is B. Now, if I want to use my my elimination method, I'm going to say, well, this is 99. This is not a scientific notation. That is wrong. This is a 99 point something. I'm not going to look at the exponents now. This is wrong. Now, the ones I'm going to think about either B or D. And then I have to think, this is an extremely small number. When I switch or shift the decimal point to the right, I have to have a negative exponent. This is a 5. This is wrong. This must be the right answer. Or you can go ahead and follow the steps and you will have this answer as the correct answer. Next. What if you have the other way around? You have a scientific notation and you are asked to expand that scientific notation into the decimal or the numerical notation. What should I do? I'm going to do the opposite. We're going to do the opposite. So we're going to start with this number, 6.74, and shift or push the decimal point how many places? 9 places. To which direction? To the right direction, because I want this number to be a big number. It's a positive exponent. So this number should be a very extremely large number. And that only will happen if you have to move the decimal point to the right 9 places. Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those empty places, just fill them out with 1, 2, 3, 4, 5, 6, 7 zeros. The expansion of that scientific notation is 6, 7, 4, and then 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros, and then put your commas. After each 3 digits from the right, you're going to place a comma. 1, comma, and that's it. Second comma, and then you're going to have another 1, and that would be the number. The next question, it has a negative exponent for the 10. I know that that's going to be an extremely small number. I need to switch, I need to move the decimal point to the left. How many places? 6 places. Let's do that. So I'm going to start with 1.52. Start here and shift it 6 places. 1, 2, 3, 4, 5, 6. Fill out these with zeros. 1, 2, 3, 4, 5 zeros. So your number is 0.1, 2, 3, 4, 5 zeros, 1, 5, 2. Any question? Okay, let's move on to more questions on this. Okay, and now it's easier. 7.3, I have 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my number is 0.1, 2, 3, 4, 5, 6, 7, 8. So I have 1, 2, 3, 4, 5, 6, 7, 8, 7, 3. That is the number. The same manner here, 4.22. It's a positive exponent. I need to push my decimal point to the right. How many? 7 places. 1, 2, 3, 4, 5, 6, 7. So my number is 422, and then I have 5 zeros. And then place your commas. 3, and that's a comma. 3, and that's a comma, and that's it. One last question for you to try before I end my webinar, and here you go. Okay, I'm going to use my elimination method here just to make it easier. Now, I see a negative exponent. So this number should be a decimal number. Anything with a whole number is incorrect. That is incorrect. That's an extremely large number. That is incorrect. The two that I'm trying to choose between is B and D. Okay, well, I have -6, then switch the decimal point to the left 6 decimal places. So 1, 2, 3, 4, 5. So I have to have 1, 2, 3, 4. So I have 1, 2, 3, 4, 5, 6. So I have 5 zeros and then 814. Which one has 5 zeros? This one, 814. This is the right answer. D is the right answer. Okay, that's it for my math part of the webinar. We learned how to add, subtract, multiply, divide exponential terms, how to raise an exponential term to another outer term, and how to use scientific notation to represent extremely large and extremely small numbers using that notations. Now, how can you prepare for the exam? Of course, you're going to study your units. You're going to do the practice questions or discover more questions. Of course, you're going to maybe, if you want to watch that webinar again and pause the videos on the self-check questions and do them yourself again. Also, for the practice questions or the discover mores, the answers are there. Check your answers and see if you're doing okay or you need help. Also, I have searched for an outside resource, which is khanacademy.org. If you go to that website, on the top left, you will see subjects. Click on subjects, click and choose pre-algebra. And under pre-algebra, you have the lesson that is titled Exponents, Radicals, and Scientific Notations. This is the one you're going to click on. And you're gonna watch the videos and do the practice questions for the exponent properties lesson, the negative exponents lesson, and the scientific notations lesson if you want. That's an extra thing to do if you would like more practice. Also, you can call for help 9 to 6 Eastern Time. You can schedule an appointment with a TA or an instructor using this link. And you can choose your time and the subject that you want help with, and we'll call you back at that time. Or you can text message 39033 and type in learn if you want to have an answer for a brief question regarding your math courses. Email your instructor is another option if you have a detailed question that you want to share with your instructor. I have two accounts here, samples of two accounts. Pick which accounts you are on. They are the same thing, it just the interface is differently set up. So follow the steps for the one that your account is matching. It's matching this setup. So that is another way to communicate with your instructor. Thank you for your attendance. Thank you for attending the extra 15 minutes. And please take a survey, just one question, rate if that webinar was not helpful at all or very, very helpful, 1 to 5. Even registrants who did not attend will have a link to the survey. I would appreciate it if I hear a feedback from you on how was that webinar helpful. Thank you, everyone. If you have a question, I'm going to wait for about 30 seconds to type in your questions. If not, then I'll end my webinar. Okay, I wish you all the best in the exam. If you need help, you have multiple ways you can reach your staff here and to get help on your algebra. Good luck and thank you.